Hello everyone. In this video we are going to study about control system. So we will see what is control system, components of control system and types of control system with examples. So first we will see the definition of control system. So what is system? Basically a system is nothing but an arrangement, or we can say that set or collection of things which are connected or related to each other to form a whole. So system is nothing but an arrangement of things which are connected to each other or related to each other. Then what do you mean by control? So control means to regulate, to direct, or to give the command to a system. So in short, control system is an arrangement of physical components which are connected to each other or related in such a manner to command, to regulate it, to regulate itself or any other system. So here in a control system, what we are doing, we are connecting different components to perform a specific task or a function. Next, basic components of the control systems. Now we will see what are the basic components of control system. First is input. So what is input? Input is a command applied to a system from an external source in order to produce output or a specific response. So here input is a external, we are applying some command from external source to produce the output. Next, control system components. So in this particular block there are different components, or we can say that devices. So devices or components to command, to regulate, or to direct a system. And what is the output? So output is nothing but the result of this particular system, or it is also called as the actual response obtained from the system. So these are the basic components. First is input, and last is output, and in the middle a block there will be a control system. That means there will be a components or devices to regulate that particular system. Next, classification of control system. Now there are two types of control system. First is open loop control system, and second is a closed loop control system. First, open loop control system is also called as non feedback control system, and the closed loop control system is called as feedback control system. So we will see first what is open loop control system, which is also called as non feedback. So why it is called as non feedback, we will see. So generally, the elements of an open loop system are divided into two parts. So the open loop system, the components or elements of open loop systems are divided into two parts. First is a controller, and the second is a controlled process. So these are the two elements of open loop system. Okay, so first is a reference input. Now reference input is denoted by r of t, and it is input signal or a command applied to the controller. And now what is controller? So controller, what it does, controller generates the actuating signal which is represented by u of t. So it generates one signal, or the controller can be a amplifier, mechanical linkage, filter, or any other control element, which totally depends upon the nature of system. Or the best example of controller is nothing but a microprocessor. Okay, so what controller does, it generates one signal which is called as actuating signal, and which is represented by u of t. Next, control process. Now what is control process? So it the signal of controller, that is u of t, which activates the process to produce the controlled output. Okay, so or u of t activates this process, and it generates the output signal. And what is controlled output, which is represented by c of t, which is actual response of the system. So here in this open loop system, there is no relation between input and output. See here, this is a reference input and this is a control output. So there is no relation between this output and input. Hence, there is no need of any feedback elements because there is no relation. Therefore, this particular system is called as non-feedback system, because there is no feedback and there is no relation between output and input. Therefore, it is called as non-feedback system. Then example, the uh, basic or regular example, we can say that real life example is a traffic signal control. So here this lights, red, yellow and green, this three lights represents the input. Then the traffic, or we can say that volume of this vehicles are representing the output. Okay, so here when the red light glows, the traffic stops, and the green light directs the traffic to start. Okay, the on and off of the red and green lights are predetermined by calibrated timing mechanism and are in no relation with the volume of traffic. Okay, so here the on and off of this particular lights, red light and green light, which is calibrated by the mechanic, we can say that it is predetermined by the any device. Okay, but there is no relation between the volume of traffic. Means if the volume of traffic is large, then timing of the green light should be more, or if the density of traffic is low, then the timing of the green light should be small, less. So there is no relation between the volume of traffic. Therefore this system is called as open loop, because there is no relation between input and output. So this system is called as open loop system. Now see, every system has some advantages and disadvantages. So what are the advantages of open loop system? So it is simple and easy to construct, cost effective, then easy for maintenance, highly stable operation. Then we will see what are the disadvantage. Now in open loop system, we are manually controlling this system. Therefore it is a slow process. Then it is not accurate and reliable, especially when input is variable. And for accurate result, it needs careful calibrations, and it affects by internal and external disturbance. So this is very important, it affects by the internal and external disturbance. Therefore it is not an accurate system. Also it is a slow process, because we are manually controlling this system. Then we will see the closed loop system, which is called as feedback control system. So this is a block diagram of closed loop system. First is a reference input, which is denoted by R of S, that is input signal. Then set point. Now here in open loop system, we have seen that there is no relation between output and input, but in closed loop system there is a relation between output and input, which is feedback by some this output is again feedback to the input to check the error. So this is called as set point, or we can say that this is also called as summing point, and which is here E of S, which represent error signal, which generates the error in that particular system. Then this controller elements and plant presented by G of S, which is called as forward path gain. Then there is a one feedback element, which is represented by H of S, feedback system feedback element, or control output is represented by C of S. So this is the block diagram representation of closed loop system. Now what is reference input? We have already seen what is reference input, which is denoted by R of T. So it is an input signal or command applied to the controller. Now what controller does, so it generates one actuating signal, which is represented by U of T. So it can be a amplifier, mechanical linkage filter, or any other control, which totally depends upon the nature of system. And the best example is microprocessor. Now what is plant and control process? So the U of T activates this process to produce the control output, and control output C of T, which is actual response of the system. Only the difference is feedback. Now what do you mean by feedback element? So the output of any control system is affected due to change in environmental conditions or any other disturbance. So one signal is taking out See, one signal is taken from output and it's fed back to the input. So this is my output C of S. So this one signal from output we are taking back to the input. Okay, so this is called as feedback. It is the tool which takes the system output into consideration and enables the signal to adjust its performance to produce desired response. Now, what is the advantage? So we can see, after taking the output back to the input, we can calculate the changes, or we can measure the errors. Also, we can adjust the performance of the system. Next, this feedback signal is compared with the reference input and generates one error signal. Now this error signal is applied to the controller and output gets corrected. So now it generates that feedback signal is compared with the reference input, and then it generates one error signal which is represented by E of S, and this error signal applied to the controller again, and then output of that system gets corrected if there are some changes or disturbance. Hence this system is said to be feedback system. Now, best example of control system is human being act as a closed loop system. One example, if a person wants to reach for a book on a table, suppose the books are kept on the table, and we want to, any one person wants to reach to the books. So reference input will be the reference position of book. So this is my input, the position of book is my input. Then what is the controlled system? In control system, one block will be the brain. So brain, what brain does, it's give the signal to hands. What is my output? Desired position of hand. Now, how to check this? Is the hands are moving towards the books are correct or not, the position of the hands are correct or not. So the eye, here eyes are acting as a feedback element. Okay, and the if the position is wrong, hand position of hand is wrong, then it gives the signal to this brain again, and brain again give the signals to hand, and then it gets the desired position of hand. Okay, next example, water level controller. So this is my block diagram of water level controller. The required level, this is my input, that water is my input, then valve, and this valve is controlled by controller. So controller controls this valve. Then there is one tank, water tank, and there is a one float position. Okay, this is my float position, and this is my output. So actual or achieved level. First is valve, which is used to start or stop the flow of water inside the tank. This valve is controlled by the controller. Then what is float? Purpose of float, it is used to sense the level of water. Then controller, the controller generates the signal to open or close the valve of tank. But for this, the controller also needs to know that when it required to open or close. What controller does, it's give the signal to valve to open or on, but it should controller should know na ki what is the when to stop or when to start. So the position of float, so here it generates the signal to inform the controller about the level of water in the tank. The level of water in the tank is specified by the controller. See, here consider level of water in the tank is below the specified level. This is my specified level, and the water level of water is below this specified level. Now, the position of the float inside the tank informs the controller. Now, this is the float. So this float, what it does, it inform the controller that valve must be open so that the water flow inside the tank. So it gives the this float gives the signal to controller, and then controller opens this valve to flow the water inside the tank. Next, once the specified level is reached, now here specified level is reached, then controller generates the signal and valve gets closed. How it generates the signal? This float gives the signal to controller that the specified level is reached. Then this controller of this particular valve, and the water stops. The closure of valve will automatically stop any further flow of water inside that tank till the next command. Okay, if the water flows out from the outlet. Okay, now here the water, this particular valve is open, and water flows out from the outlet, or then the position of the float will automatically inform the controller the water level is again desired, uh, from the desired level. Okay, so here it automatically informs this controller that the water is decreasing from the desired level, so the controller further sends the signal to again open this valve, and then the valve is open, start the flow of water inside the tank. Here the controller continuously monitor the position of float inside the tank. So here controller continuously monitoring. Okay, and according to this, it sends the signals to valve, so hence the float act as a feedback of this water level controller, and the tank here act as a process which is need to be controlled by the controller. Next example is temperature control system. So this is my block diagram of temperature control system. See this here, this is a tank. Water is inside, then steam flow, there is a one valve, there is a pressure sensor, and here comparator which used to set the temperature, and here after this hot water out from the tank. So this is my reference input, this is my summing point or set point, this is a valve, steam flow, tank, and one feedback element, that is pressure thermometer, and this control output. So here, first, to have a predetermined temperature of water, steam from a valve is mixed with the water. Now here steam is mixed with the water. Hence, here pressure thermometer act as a feedback element when a reference input is provided to the system. This is my reference input is provided to the system. Then the valve generates a control signal to provide the required amount of steam. So here what a valve generates, it generates a signal, control signal, to provide the required amount of steam. Next, when steam flows, then the temperature of water is measured by the pressure thermometer. This temperature gets measured by this particular pressure thermometer. Then the comparator compares the pressure with the reference input. Okay, that is desired temperature given to a system. We have already given one temperature, desired temperature, or we have set one temperature. So it compare what it comparator does, it it compares the value of reference and this temperature measured on by the thermometer. If the desired temperature and generated temperature are equal, see temperature of water is equals to set temperature. Okay, if the desired temperature and generated temperature are equal, then the control signal is generated and the flow of steam is gets stopped. And in next, if the desired temperature and the generated temperature are not equal, suppose the temperature of water and the set temperature, whatever set we have set the temperature, these are not equal, then the error signal is generated, and the controller controls the temperature through the turning on the valve, and again the steam flows through the water. Again, the comparator compares the temperature of water and set temperature until it's reached the desired level. Next, in this way, the continuous process inside the system take place, and controlled level of temperature is achieved. Now there are some advantages and disadvantage of control system. So first advantage is it increase the productivity, improvement in the quality and quantity of the products, then relief of human being from hard physical work, and economy of operating cost. Then they are more reliable than human operators. Closed loop system can be adjusted to optimum control performance. Then systems sense environmental changes as well as internal disturbance and accordingly modify the error. So here it is error can be modified through the closed loop system. Then what are the disadvantages? So it is more complex design and expensive, then it requires some maintenance, and this maintenance is difficult as it involves the complicated in electronic devices. Then it is less stable as compared to open loop system. Hope you have understood what is control system. Then there are different classification of control system: open loop system, closed loop system, examples of open loop system, closed loop system, and what are the advantages and disadvantages of closed loop system and open loop system.